Alright guys, we are looking now at 3.9 transforming to linearity, which is the final exercise for the chapter. And what we're going to be looking at is how we can transform or modify, or as the slide says, linearize our sets of data in a scatter plot to make it a more better fit into a linear pattern. This will not give us a perfect linear straight line, but it's to transform or modify our data to get as close as we possibly can to a linear form. And we can do these transformations both to the x or to the y values. So effectively what we're trying to do is to get our r value as close as we possibly can to either 1 or -1. And in the scope of further maths, we are just looking at these 6 transformations here. It's quite often easy to think of 3 and then changing it for the x or the y. So first we have our log transforms, which we have y versus the log base 10 to the x, or the other way around, log base 10 y against the x. We have the quadratic transforms, where we simply square either the x or the y, and we have the reciprocal transformations, where we simply take the reciprocal of one of our variables, or simply 1 divided by a variable, in this case x, in the other case y. So the way we can actually decide how we're going to transform depends on what our first graph actually looks like. So as it says in here, is a worksheet on Moodle which gives us a step-by-step instructions on how to do it. Up here there's a kind of a cheat sheet on what you should use, but the next few slides kind of sum it up really nicely. And like on the scatter plots, we do not want to see you guys writing these ones out by hand. It is nice and easy simply just to cut them out and stick them into your book. It'll be the most accurate diagram you can actually get. So let's look at this one, the quadratic transforms. If for some reason you need to stretch your x values out either above the line or below the line, you should use your x squared transformation. So that just means you're simply taking all your x values and squaring them, and that should push these values out and get close to this line as possible. If we need to push our values up in the y direction, we simply do the transform on our y variable, so we square the y. So it doesn't matter if it's below or above the line, it will stretch them all the way up. If we're looking at the log or the reciprocal transforms, it's simply the opposite. So if we need to compress or bring our variables back towards one of the axes, that's what we're going to use. So if we need to move it back towards the y-axis, we use the transformation on our x variable. And if we need to pull those variables down towards the x direction, we do that on our y variable. And as you can see, for all of these, you can either use the log or the reciprocal, and it will do the same thing. The best thing to do is give them a try and see which one gives you closest to 1 or -1 as possible. So what we're going to be looking at here, this slide quickly steps you through on how to do these transformations on your calculator. I'm not going to go through them in too much depth because the next video up will show you how to do this on the CAS like we've done in previous videos. But the one thing I really want to point out or keep in mind is, on this example, we've got them labeled as x and y. I highly recommend don't use x and y's, label them as whatever the data has been given you. It just stops any of these conflict boxes coming up, or any issues that you may have later on, because your CAS likes to store information in x and y. So just remember, when you label them, try to label them something different other than x and y. But how we actually do our transformations, once you've set your data up, so in this case we used x and y, you're going to go to your next column across, and that's where your transformation is going to be. So we've labeled it T for transform. It doesn't really matter what you label it as long as you know what it is. And in this formula box is where you put your transformation. So in this case, we're doing x squared. So we're taking the x column and squaring it. Once you've done this, it will automatically fill in the values for you here. But the next video will go through it in greater detail. Over here, we're showing you how you can get your rule for your regression line and your A values and your B values. It's exactly the same as what we looked at when we did regression lines on the CAS last time. The key thing to keep in mind here is, whenever we're choosing our X or Y list, you have to make sure whichever one you transformed, in this case you transformed our X, the transform column now goes in here, not the original value, because you're now graphing your transformed value. following on from that, when you rewrite your equation, as you can see here, we've got an x squared, because that's the transform we did to get our straighter line. Not x, we've got x squared. So you have to make sure whenever you do a transformation, you have to update your variables. So if you use, like in our example, you transform the x, you put that there. If for some reason you have to transform your y, this y over here will be different. So you have to really make sure you put that in, because that's a full mark you're going to lose at the end of your working out if you've missed that little step there. Otherwise, that kind of wraps it up. It's stuff we've looked at already. The new part here is knowing how to transform or manipulate our data around, and then from that point onwards, getting our new equation or regression line there. And that about sums it up. Congratulations for finishing chapter 3. Well done. The next video coming up again will be the CAS one, but awesome. You smashed out chapter 3. Well done. Well played. Good work.